Is the sound okay?
Yes. Yeah, the sound is good and people are starting to file into the room. So we'll just give people a couple of minutes to file in and answer that survey of where are you located? I always like seeing this. If where you're from is not listed, then just let us know in the chat. I always love watching this to see as we see people from across the country join in. And once again, Gord, you'll be happy to know we have representation so far from British Columbia, Alberta, Manitoba, lots from Ontario, Quebec, the Atlantic provinces, and the United States so far.
And as my buddy Greg Barron from Australia, from time to time, he listens in.
Oh, that's fantastic. You know, I don't know. He'll have to put that in the chat if you or acknowledge that through the other there. So far, I don't have anybody in the other, so maybe not yet.
Okay.
It's got to be like, isn't it 1 a.m. there or
yeah,
something?
Exactly.
Yeah. So
what's
now that's a super fan, Gord.
There you go. And how is my sound? Are we okay?
You sound great. You sound great. Okay, so I'm going to end that polling. It looks like most people have responded. So I'll just share that result for everybody to see. Stop sharing. There we go. So mostly from Ontario, but we have representation from both Canada, coast to coast, and the United States. Just one more, let us know what your occupation is. So I've listed a number of different occupations. We've got builder developers, renovators, construction and trades, EAs, the government, academia. And if it's other, let us know in the chat so we can see where you're from, what you're doing, what your occupation is. So we'll just let those numbers come in. All right. Looks like I think we're pretty close. All right, so I'll share that. So excellent. It looks like we have predominantly builders and developers, so that's good. Renovators, construction and trades, right across the board, EAs, utilities, and others. So it looks like we've got in other residential sector, council, a columnist for the HPAC magazine, sales, new home warranty adjuster. Excellent. Excellent. Okay, so this is great. So thank you all for participating in those polls. My name is Stephanie Coleman. I work with Building Knowledge as the Marketing and Business Development Manager. And so today we have Gord with us, and he is going to be speaking on humidity control and the key principles that every builder and homeowner needs to know. So Enbridge is the sponsor of this webinar. And I don't believe Susan is able to join us today, but we certainly want to acknowledge Enbridge's contributions to the industry and their support of the industry through training programs such as this. And so we're looking forward to today's session. So Gord, I'm going to hand it over to you.
Great.
I'll stop sharing my screen.
Oops. Yeah, continue. And thank you, Stephanie. Let's just validate that you can see what I'm up to.
Yes, I can. And actually, I forgot to mention, if anybody has questions that they want to ask of Gord, just put that in the Q&A function that you see at the bottom there. And we will, what I'll do is I'll interject every now and again and ask your questions. If you have just some general comments, you could put those in the chat. But the Q&A is a good mechanism for fielding the questions that you have. So. Okay.
And Steph, you know it's okay to interrupt me at any point. So thank you very much for that. And thanks, folks, for being online. I'll echo Steph's comments about, isn't it great? Enbridge is such a wonderful industry partner. It's so amazing. It feels like every week we're working with them on something or other, always in the vein of let's help builders. They match, frankly, what we like to do is just help builders make better decisions, make it easier for them to move along. And Enbridge just says, so generous in this particular times to help us with these kinds of topics. And Stephanie said humidity, and I'm going to expand that topic just a little bit to think more about moisture in total, moisture and moisture control. And I kind of promised, it was a bit of a hook, I guess, of 3 key principles that every builder needs to know or everybody needs to know. There's obviously going to be more than 3, and hopefully there's 3 key ones to you, 3 things that you would learn out of today. That's really what I'm most interested in. It is a topic near and dear to our hearts that we absolutely have to be careful of as we build more and more energy efficient houses. Andy always likes to say, let's avoid unintended consequences. And moisture is the biggest unintended consequence. So that's what we want to chat about. And in terms of where we're headed with this today, water, moisture, and humidity, and they're going to go, aren't they all the same? Well, they all are the same, but how they impact and how we worry about them perhaps are a little bit different. It's water in different forms is really what we're thinking about. And I do want to think about both new and existing houses and the effect moisture has on the houses. And I'm going to spend a fair bit of time on windows and walls. I'm not going to spend much time on attics, for example, roof leaks. We're going to spend some time on basements, but we'll talk about penetrations. And then I just want to help you with the indoor relative humidity issue as well. So those are kind of the 3 areas of focus, if you will, that we're going to chat about. And of course, along the path, some installation methodologies. And so I always like to start with my neighbor's house up in Southampton, Ontario. We built a net zero house on an empty lot beside this house built in 1868. And did this house have any problems? Is this house experienced over its 160 years or so of existence? I think it's 1868 is when it was built. And you'll notice it's stucco. That stucco we know was applied somewhere about 100 years ago or just before 100 years ago. Why would you slather stucco over top of perfectly good Eastern white cedar lap siding? Well, it's because Eastern cedar lap siding, of course, leaks air, leaks moisture. And when you put the stucco on, it creates a really nice drainage layer in behind the stucco between it and the cedar. And this house worked because it had good drainage and more importantly, it had good drying potential. That is, this building had no insulation in it. So it would get wet. You've seen here, he stripped off the stucco, and you'll notice that some of the boards had to get replaced along the side of the door, for example, underneath the windows. But even though the building leaked profusely, it lasted a long time, not because they were brilliant builders and built, we always hear not built the way they used to. Well, these guys weren't particularly good builders. They just magically had drainage behind the stucco, and they had drying potential because there was no insulation in the walls. So keep that in mind. And if we fast forward now to our era, you think about what's changed with respect to moisture management, and you have to think about the complexity of buildings. Look at the complexity of this building, the cladding systems, the windows that are exposed, the gable ends, just the mere size of this building gives you a cause for pause, if you will. And I do, and you guys have heard me say this many times before, so I won't spend much time on it. Every time you add insulation, you need to recognize that you've reduced the drying potential in your buildings. So in the 1990, you were building R12 walls, then we went to 17, then 19, then 24, and some of you are now at 25 to 30. Past those folks are at 45 to 50. You've reduced drying potential each one of those stages and phases. So when somebody says to you, I've done it that way for 30 years, you would say, then it's time to change because you have new risks that you need to worry about. And yes, we're building them more airtight. I think that's a great idea, but we do need to understand that old building, my neighbor's building or Mabel's home, had really a leaky building and therefore good drying potential as a result of that because it was warm air that was leaving or escaping through. So we've reduced the drying potential of buildings, and we're using more sensitive materials. Now, I'm the first one to tell you OSB is a wonderful building material, structural strength to weight ratio, its consistency and dimension, wonderful building material, but I think we'd all agree it is more sensitive to water and water damage than, say, that Eastern white cedar lap siding. So we have to be more careful about that aspect. And we are putting more windows in our buildings, which means we have more and more penetrations that we have to worry about, larger windows, windows that move more. Oh, and you're using different color windows. You're all now using black windows. Did you know the thermal expansion and contraction of black windows is more than the thermal expansion and contraction of white vinyl? And so we have to think about that expansion, contraction, what implications that might have. And from an interior moisture, content, we have to think that we open those windows less. So all of these changes that have taken place. And I want to add to you this little complexity that we've added more insulation, we've added better windows, which means we've reduced sensible loads. That is the temperature difference or the temperature load across buildings, but we've actually increased latent loads. That is the amount of moisture in the houses. Because of more time indoors, because of tighter buildings, because of more plumbing and so on, we have more latent or moisture loads inside our houses. That gives us implications. And then, of course, we love to use more moisture. I love that one at the bottom right. Wow, do you think he's got moisture problems in his house? He's got this saltwater fish tank. What is that? I think it's 9 feet long and 8 feet high, something like that. Beautiful, right? But do you think this presents any moisture issues inside the building? Look at the shower head up top there. This was a high performance house in Midland, Michigan. This is a 16-inch by 32-inch shower head that takes 2 tankless water heaters to operate. And this is a client who wanted to build a very energy efficient house and then kind of apologized for this very large this very large shower head. So are we putting more moisture in houses than ever before? So those are the challenges. And then interesting enough, gas ranges are their own source of moisture. The products of natural gas combustion is water vapor. One of the single biggest elements is water vapor. So even those are presenting moisture challenges in houses. So when you add all of this up, you think about more wetting potential, right? Those risk factors of that building that you can see there, the flat roofs, the parapets, the different cladding systems. So more wetting potential, more penetrations in buildings, and then different water management principles. That is, each one of those cladding systems works just a little bit differently in the way they manage moisture. And of course, those more sensitive materials that we have to think about as we move through this. So that's the little summary. And you guys know this. All I'm saying to you is things have changed. Whatever you used to do is no longer good enough. And then add to that, you remember John Straub at our spring training camp talking about flat roofs and no overhangs, those kinds of things, the challenges go up. And then we just want to remind ourselves that moisture comes in 3 forms: solid, liquid, vapor, right? 3 forms: solid, liquid, vapor. The one that we're most interested in specifically today, but overall, is water in liquid form. That is, we could kind of care less about the ice and so on the right-hand side until it turns into a liquid, until it melts. We could really care less about water vapor until it condenses on those windows that you see at the top. So it's water in liquid form that we worry about. That's not to say we don't think about where the water vapor might be coming from and can we control it at sources, but it's really in water in liquid form that we're interested in, which begs the question, is moisture good or bad? And I think you would all agree, moisture is good for comfort, it's good for health, it's good for furnishings and finishings, hardwoods and grand pianos and so on, those kinds of things. But it's bad from a condensation perspective, it's bad from a mold perspective, bad in some cases from a health perspective. We'll chat about that in a minute. It was just the CHBA Net Zero webinar I was pleased to do on Tuesday that talked about the connection between COVID and moisture levels in houses, humidity levels in houses. So moisture is both good and bad in houses, and sometimes bad for, of course, finishings and furnishings. That's where we need to get to. And so it's good for the people in general, typically bad for the building. That's kind of the way we'd like it. And where would we like to be? Well, I mentioned on Tuesday, I'll mention here again for those who weren't there, 40 to 60%. This is called the Sterling chart. It was developed in 1973, recently validated by ASHRAE to say that on a whole number of levels or parameters that 40 to 60% relative humidity is really where you'd like to be, 40 to 60%. It's better for molds, it's better for viruses, it's better for mites and so on, that we tend to be able to optimize conditions in houses at that 40 to 60%. So keep that in mind as we go through this. If I said to you in Canada, can I get to 40% in the wintertime, you'd go, not in Edmonton, I can't. Not in northern New Brunswick, I can't. So how do we balance that? And so one of the first key principles out of today is to recognize a new metric. All of your clients, all of the literature says 40 to 60, 40 to 60. But we need to fine tune that and say, nah, it's really about this. It's 50% plus or minus 5 in the summer. We really want to avoid that 60% because that puts you at risk for mold and mold propagation. So you'd like to stay below 60. Now, let's be really clear. 60% for a couple of days, 60% certainly for a few hours, even a couple of days, that's not what we're worried about. It's okay if moisture goes to 60, 65 for a few days out of the summer in a hot, humid period. But on average, over the course of the summer, you'd like to maintain 50% plus or minus 5. And in the wintertime, 35% plus or minus 5. And I say that advisedly, 35% or higher is fine as long as you don't have condensation. And I would say to you, that's why you want to use triple glazed windows. Stop talking about triple glazed windows and how they save energy. Start talking about triple glazed windows and how they allow people to have higher levels of moisture in their houses so they feel more comfortable, so the grand piano doesn't go out of tune, so that the hardwood doesn't buckle, their skin doesn't flake, and so on. Allow people to have higher levels of moisture. Triple glazed windows are a health device. They allow you to get to higher levels of moisture. And again, I know in northern Alberta and northern Ontario, even with triples, you might only be able to get to 35. And again, remember, it's okay if it goes lower than 30 to 35 a few days out of the year. But on average, over the course of the winter, you'd like to maintain that 35 plus or minus 5 to avoid condensation on surfaces. But it does beg the question, and I suspect everybody on this call knows, but I thought I should just touch you up. You know, the definition of relative humidity. Definition of relative humidity, the amount of water vapor in the air compared to how much it could hold at any given temperature. And if you see the beaker there on the left, 21 degrees Celsius, 50% RH. If I simply take that air and take it outside, now think about this kid's birthday party, you blow up balloons in the wintertime. In the house, it's 21 degrees Celsius, 50% RH. Inside the balloon is 50% RH, I guess, plus your respiration. But you take that balloon outside, what happens to the balloon? It shrinks, it gets more dense. The balloon shrinks, the air gets more dense, and the relative humidity goes up. We didn't change the moisture content, we simply changed the temperature, and air that was reasonably comfortable and dry, 21 degrees and 50%, now is at 10 degrees Celsius and 100% relative humidity. Now, that's an interesting number. Go the other way. That means if it's 10 degrees Celsius outside and raining, it's 100% relative humidity. If I bring that air in and warm it up, its new relative humidity is 50%. The air that looks really wet, right, 100%, is actually reasonably dry, comfortable air when I bring it in the house. That's a really nice piece of learning for you. Obviously, we're in summer now, but think about the fall, think about the spring. You're drywalling your house. They want to dry it out. If the air outside is cooler than 10 degrees Celsius, the air outside is typically drier than the air inside. Air outside below 10 degrees Celsius is a reliable drying mechanism. People have condensation on their windows and it's cooler than 10 degrees Celsius out. You could bring in some outside air, HRV, ERV, to reduce their moisture. But I want to show you just how tenuous this gets. Look at this little piece, 23 degrees Celsius. This is where we think people will be comfortable, right? That's where we design heating cooling systems too, specifically cooling systems. Your cooling system is designed to be at 23 degrees Celsius, and we like that 50% number, right? Well, I was just at 4 houses last week, and their clients are going, 23, that's way too hot. I want my house at 20 degrees Celsius. Look what happens to that air. The same air, the same moisture goes from 23 and 50 to 20 degrees Celsius and 60. And they're saying, and we're still not comfortable. We want it even cooler yet. The reason they want it cooler yet is because it's too moist. They're getting that hot, that cool, sweaty night feeling, that damp, sweaty night, because they haven't removed the moisture. So if we're going to cool the air, we also need to remove the moisture. Now, how do we help clients with that conversation? You guys know Robert Bean does great work on this, but I just want to assure you that this two air streams, the 23 degrees Celsius and 50% RH, is exactly the same dew point, same moisture content, overall moisture in the air, as 20 degrees Celsius and 60% RH. And so we need to have a little better understanding. One of the key principles today is the relationship, especially in summer, in this case, between air temperature and relative humidity. When the air temperature goes down, the relative humidity goes up. It puts your buildings at risk from a mold and moisture perspective, and it doesn't actually improve the comfort because you're still feeling that hot, sweaty night or that cool, sweaty night in this particular application. So next piece is, so we all need to have a good hygrometer. And the problem with hygrometers is all of these hygrometers are in exactly the same humidor, the same climate controlled condition. It's actually at 42%. And look at the range from 20.9 up to, what's the worst one? 51.5, right? So homeowners have a hygrometer. My moisture's fine. Let's make sure we're calibrating our hygrometers. Everybody on this call needs to immediately go out and buy themselves a good hygrometer. You're probably going to spend at least $100 to get there. And then, even then, calibrate it. And how do I calibrate it? It's actually pretty simple. Go Google it, measure calibrating your hygrometer. CMHC put out this publication. You take a cup of table salt and you put a quarter cup of water in it, in a coffee cup, and you stir it around for a minute or two. And then you put it inside a Ziploc bag with your hygrometer. And within a reasonable period of time, this says 8 to 12 hours, your hygrometer should get to 75%. I've actually taken bags of salt to clients' houses. I knew I was driving a long way. They said they had moisture problems. I wasn't sure if I could trust their hygrometer or not. And so I took a bag of salt to their house. And while we did the investigation, we looked and we calibrated their hygrometer. And the good news was it was pretty accurate, but at least then they and I had confidence that what they were measuring was in fact the problem. So a calibrated hygrometer is always a nice piece. So hopefully that's good learnings for you right now that says, what is the right moisture level, the right balance, and how do I measure that? How do I maintain that? I'll come back to that at the end of the session in terms of managing that moisture summer and winter, but we'll move from there. And then I want to move on to liquid water. I'll say moisture in the enclosure, let's call it, and the methods of moisture flow. And the first method, no surprise to you or I, gravity, right? Liquid water flow, rain, water leaks, plumbing leaks, and so on. The second is capillary flow. In the US, capillary flow. I got to speak both languages apparently on the call today, but capillary flow, water wicking up, rising damp, if you will. And we tend to build our buildings out of materials that are hygroscopic, like concrete and wood. So that rising damp, that moisture rising up from the soils is always of interest to it. The third method is air transport. Now, we've covered this in air tightness sessions before, so I won't go too deep on this. I'm going to spend most of my time today on liquid water flow. This session that we're doing here today is actually a small snippet of a full day moisture session that we do on behalf of Enbridge at various times. We've done it in person, but today, so I'm going to concentrate on liquid water flow. And the fourth is vapor diffusion. And again, I'm going to leave that off for today, other than to say, if you can make sure your buildings are liquid watertight and you can control rising damp, capillary flow, you don't need to worry about vapor diffusion in new houses or old houses unless it's an indoor swimming pool or something like that. So it's always about managing liquid water is where we'd like to go. And my buddies at CI, Construction Instruction, for those of you who don't have the CI app, go ahead and get it. I love this little animation. It helps us understand the 4 Ds of water management: deflection, drainage, drying, and durability. And remind yourself that we used to rely on roof and roof overhangs, those little ranch bungalows with wide overhangs. We used to rely on those roofs. And now we're relying on our cladding systems, the brick, the stucco, the stone, and the siding to deflect water away. And that's good to know. But all of you need to recognize none of those cladding systems are actually watertight. Brick, stucco, stone, and siding let in 1 to 5% of the water. And when it gets in, we need to let it out. We need that word drainage. We want drainage behind our cladding system. A key word out of today, key principle: how is my building draining? I need to look at those exterior walls and say, when water gets in, not if, when water gets in, how does it get out? And how do I get it away from the building? Look at your buildings in a new way starting tomorrow that says, where's the water draining to? Third on the list is drying potential. We'd like our buildings to be able to dry to the outside in the winter, to the inside in the summer. Most of our drying potential in Canadian context is to the outside. So we'd like to make sure the building materials on the outside of our buildings are indeed vapor permeable. And the last on the list is durability of materials. And durability is nice, pressure treated and so on, but we would say spend your money on deflection and drainage. Drying, we'll talk about it a little bit, but let's move towards really good deflection and drainage is where we like to go to. And I just like to highlight those again. First is deflection. Second is drainage. Third on the list is drying. And as a last resort, okay, let's look for materials that are more or less susceptible to water damage. But don't look for the perfect material, look for the best drainage is what you want to think about. And when you think about this building, if you counted the risk factors on this building, look at the different cladding systems, look at the flat roof, the parapet sections, look at on the main floor, the ground level, that in fact we have unheated space or unconditioned space above conditioned space. And so there's lots and lots of risk factors associated with this. And this builder, great builder, said to me, it's just, I've never experienced these leaks before. And then he immediately said, but I guess I've never built buildings like this before. These are complicated buildings, and perhaps the architect could have helped with a little better design detailing of those risk factors. And so let's just start with a really simple one. I've been showing this slide for a long time, but it's okay because it shows the power of good design. It starts at the design phase. Does this give you good deflection? And my key to this slide is this: whose responsibility is this? And I would say the designer shouldn't have designed it. The framer shouldn't have framed it. The window company shouldn't have shipped the window off. The roofer shouldn't have roofed it. Somewhere along the line, somebody had to say, this isn't going to work. And there was 50 of these houses built in a neighborhood, and 49 of them had to get repaired. 49 out of 50. Now, what happened to the other one? Actually, they were hardly ever in the house. It was facing south. It had good drying potential. So 1 out of 50 didn't leak. And I will say this to you, not all buildings leak. Let's be really clear. Not all buildings leak, even if they look like this. But in fact, we need to recognize the potential for leakage. So making sure we're watching. My partner, Mark, always likes to say, put on your water management glasses. Watch the pattern flow, even go out in a rainstorm and watch where the water's running. It's really, really instructive. And here we would say the trimmer shouldn't have trimmed it, right? Somebody along the path had to say, we're not doing this anymore. Let's fix our designs. Let's get there. Here's again, good examples of bad deflection. That thinking on the left, that window really needed a little bit of a roof over it, right? A little eyebrow. The window on the right, the one I think it's circled there, the window on the right, could I have changed the location of that window? Could I have changed the roof line? Or if I'm not, then I got to think about proper kick-out flashings and so on to get that done. There's that circle, sorry. That window's at risk. And the good news is it's not a lot of water coming off that roof. It's not a main part of the roof, but still we know that window is going to fail sooner than any other window that we need to think about. And then, as I said, good drainage. This is a traditional 3-coat stucco on 1 layer of building paper. And we know this doesn't work. We know that historically, stucco needed 2 layers of paper. Why? Because it needed drainage. 2 layers of paper. There's nothing magical about the building paper except that the first layer bonded with the stucco, got wet, dry, wet, dry, wet, dry, wet, dry. And when you think about paper getting wet and dry, what happens to it? Well, it crinkles, it shrivels. And that crinkle and shrivel created a really good drainage plane. So we need good drainage. Here's examples again. Bad drainage, a really good siding material, cement board siding, a nice sheathing product that's really immune to water, but in fact, we get water wicking up at least 6 to 8 inches. And look at those unprotected fastener locations. Not the joint where it's taped, I'm okay with that, but what about water wicking back up? This product, these materials really would benefit from a little bit of drainage. And what's drainage? Drainage is an air gap. It's a 1/4 to 3/8 of an inch, 10 millimeters, John Straub would say, is sort of the Canadian number. Drainage behind your cladding materials is really, really important. And drainage isn't that difficult to do, right? So there on the right-hand side, brick in itself, assuming there's no mortar, notice the mortar net, the black mortar net, the picture on the right, making sure there's no mortar entrapment. Even the insulation they're using, the mineral wool insulation, that's either rock wool or thermal fiber, that too is a good draining material. On the left-hand picture, the water-resistant barrier is behind the foam insulation in this case. but you put a draining house wrap. This is a crinkled or grooved house wrap that gives you drainage of water. Drainage is your friend. Look at your buildings again from a drainage potential. As I say, it's pretty easy. There's a mortar net or a rain slicker on the left-hand side. There's the airspace behind the brick. Brick is highly forgiving as long as we've got good clean airspace, and you'll see in a minute, as long as we have good abilities to take that water, all the water gets behind the brick and make sure it gets out from behind the brick and doesn't start wicking back up again. So we do need to think about bottom of wall when we talk about brick. I've seen 3 failures in the last 3 weeks due to improper, I'm going to call it through wall flashings. Hopefully you know that term. Brick flashing, some might call it. 3 failures just in the last 3 weeks. Just happens to be that time of year where we start to see those kinds of things. And next on the list is drying potential. Some of you may have seen the slide before, but this is Winnipeg, Manitoba. This is 5 different house wraps used on the same building. And I asked the builder, what's that about? He says, well, I'll leave it up to the siding contractor. Really? You leave it up to the siding contractor to decide what materials are going to protect your buildings. And who holds the warranty on the building? Well, the builder said, I do. Exactly. I asked the sider, what's going on here? He goes, well, doesn't really matter. They're all the same, right? Well, in fact, they're not all the same. In these 5 products, there is a difference of an order of 20 times difference between the permeability of these materials. One of them has the same permeability of OSB. In other words, not permeable at all. The other one is 20 times better permeability, 20 times the drying potential. Which one would you want on the outside of your buildings in a cold climate? You'd want a building material that was able to dry to the outside. Oh, and their water holdout capabilities. Again, a difference over 10 times difference between their ability to keep out liquid water. So make better choices. When you're looking for a house wrap, don't look at the brand name. Don't tell me, don't wonder if they'll put my name on it for you. No, I want you to think about 3 physical characteristics. How well does it hold out water? It's a technical term. It's called water holdout. Make a note. Ask your house wrap or water resistant barrier manufacturer, what's your water holdout? 2, ask them for their air tightness, their air holdout. It's a technical term. What's your air holdout? And 3, ask them for your vapor permeability. And in Canada, you'd like a vapor permeability. The higher, the better, but in at least 60 nanograms. And in fact, you'd like to be much higher than that. You'd like to be 600 nanograms is where you'd like to be. In a US metric, that's 20 perms, 10 to 20 perms is where you'd like to be. So make sure your water holdout, air holdout, vapor permeance, you'd like it more vapor permeable. The higher the vapor permeance, the better is where you'd like to be. And then, of course, you want to think about durability of products. And I'm looking at the product on the right. This slide, you can't really see it here, but the homeowner saw it. I was out with the homeowner and the builder. We were doing a site walk. And on the building paper itself, it said, for best results, use 2 layers. And the homeowner said, how come you don't use 2 layers? And the builder said, well, that's only, best practice. And, you don't have to, you can do 1. And the homeowner said, for $500,000, I thought I was buying best practice. And the builder's like, yeah, you're right. We should probably use 2 layers. Why 2 layers? Because of the durability of this product. After, I think it's, I may be wrong on this, 30 days, this product no longer maintains, 30-day exposure, no longer maintains its water holdout. And you're going to say, well, bricklayers are putting on, it's not exposed for more than 30 days. Fair enough. But if it is more exposed than 30 days, that's one of the reasons you want 2 layers. The second reason is the 2 layers gives you drainage potential. The product on the left, a good product, but unfortunately it's been left on too long. Its coating has been rubbed off by wind and wind abrasion, and it no longer is maintaining its water holdout capabilities. So make sure we're looking after those elements. And then it's about compatibility. I'm gonna really hit you hard on this one. I'm gonna say to you, there's great manufacturers out there. Rely on the manufacturers to get you a letter of compatibility. Is anybody from London on the call? I think it was, 6 summers ago? City of London stopped all construction dead and said, we're not issuing another permit until I get a letter of compatibility from every manufacturer who touches another manufacturer's product. And I see this all the time. I don't know if you know this, some vinyl frame windows will tell you you cannot use asphalt-based tapes or caulking materials next to them. The rubber-based products, the asphalt-based products, actually attack the vinyl. So we want to be careful. And I'm going to say to you, start challenging, just write a note to all your manufacturers and say, hey, what are your products compatible with? Is this water resistant barrier compatible with the flashings that I'm using? Is this tape that I'm using compatible with the foam that I'm using on the outside of my building? Letters of compatibility. This building, 6 different manufacturers, all at this house. I don't know if you notice inside the window, it's not even drywalled yet and it's already leaking. And 6 manufacturers are all pointing going, it's not me. In fact, the flashing material, the tape that you see there is an asphalt based. It avoided the warranty on the windows. The house isn't even completed yet, and the window manufacturer was there saying, sorry, you've already voided the warranty on my windows. So make sure you have compatibility letters or assurances of how your products are working. I just thought you might be interested in, this is my buddy Justin. This is a picture from Finland where his family, it's actually Norway, where his family is from historically. And he took this picture when he was back visiting his ancestors. And this was from the 1800s. And this was called at the time rosin paper. But notice the 2 layers of the rosin paper, and it's done okay since the 1800s. And typically it was waxes or resins or asphalt, basically just to make the paper last longer. And it really relied on the drying potential of walls. That's why building paper used to work just nicely, because it got wet and then it got dry. Then it got wet, then it got dry. The problem with our walls is they get wet and stay wet for much longer periods of time. So I need you to think about whether building paper is still the right product to use. Okay, behind brick as a layer, as a bond break layer, maybe that's the way we want to use it. But is it really the water resistant barrier that you want on your buildings? It was grandfathered in as a weather barrier. It was never really tested as a weather barrier. It just said, okay, go ahead. We've been using it, so keep using it. And I would say if you are going to use it, 2 layers gives you much better protection. Anyway, I have a whole half hour on asphalt impregnated papers. If someday, if you're interested, I'd be happy to walk you through that. And then, of course, it's seldom the material itself that's the problem. It's always how it was installed. It's about getting the details right. It's even if I'm going to use building paper, let's make sure that it's integrated correctly, shingled and lapped. And I got to say to you, 2 of the leaks that I went out to in the last 6 weeks, 2 of the leaks were just this. The paper put on in the wrong sequence, the flashing details. And you're going to say, really, after all this time? This brings up another point. I'm going to say to you, we need to remind all of our trades folks every 3 months. I need to say this. Of course, your siding folks are good folks. Of course, your framers are great folks. But they need to be reminded every now and again that water runs downhill. They need to be reminded. And it's not because they're not good people, they don't want to do good work. It's just that we're all human beings. We all forget. Every manufacturing facility out there has repeat training programs. People have to be recertified. Anybody ever taken CPR training? You've taken CPR training? Do you remember what you took? I remember taking CPR training and 3 months later thinking to myself, oh my God, I've forgotten already. They actually made me do the demo and I'm thinking to myself, do I pump 6 times, 5 times? What is it I do? And I find myself having to go back and take refreshers. The same is true on walls. They need refreshers, that water runs downhill, that the sequencing matters. So commit, please. And it's not long training. They don't even need this hour. They don't need Gord Cook there. What they need is on-site, a little 20-minute conversation. Hey guys, these are the approved materials. Remember, no substitutions. And let's make sure that we're sequencing in the right order. Some builders and commercial projects would actually use mock walls to make sure that it's done correctly. I know a custom builder who has on the back of his truck a mock wall that he takes to every job site and leaves it there during construction and says, you're using these materials in this sequence or I'm going to make you do it again. So mock walls are a really nice way to make sure it's done correctly, a nice daily reminder of how things need to get done. So that's sort of the principles, if you will, of water management, deflection, drainage, drying, and durability. I want to do just a few minutes on foundations. And why is that? Because somewhere in the last 50 years, right around the age, for me, around age 12, my dad decided we should be living in holes in the ground. That is, the house was built in 54. My dad didn't finish the basement until about 1969. And I'm thinking to myself, we used to use that basement for shooting hockey pucks, and mom did laundry. My dad finished the basement, you know, the nice senior paneling, the wet bar. We never used the basement again. Why? Because it was a dark, damp location, had no end of problems thereafter. It had the potential to dry to the inside from 54 to 69, and all of a sudden it couldn't dry anymore, and we had moisture problems. And if we're going to live in holes in the ground, don't. But if we are going to live in holes in the ground, let's make sure we're doing a better job and understanding the challenges around basements. Lots and lots of moisture sources, lots and lots of insects, so on and so on. It's really powerful and important that we understand just the challenges associated with basements. And I'll just give you a quick example of this. There's a house, this is in Ottawa. It was built in, looks like the 35, 40 range, 30s or 40s. Can you smell this basement right now? Does this house have moisture problems? And literally from the street, you can see the moisture problems. Look at on the right-hand side, the siding bleeding down over the brick. Actually, that's not a moisture problem. That's just a bad paint coating. But there are moisture problems from the street that I'll show you. But I just want you, can you smell this house right now? And we've all smelt these basements. Is it a healthy basement? As an example, there is the outside on the left, the spalling of the paint. And you ask the question, how long has that been like that? Now, if they said it's been like that for 35 years, we haven't painted it for 35 years, okay, that's not a problem. But when they tell you, yeah, it's the darndest thing, we paint that every 3 years and it always flakes off, that's a good indication of moisture movement. That moisture, good news, is drawing to the outside. But go down into the basement in the cold storage room, and that same wall is also drawing to the inside. Notice that efflorescence on that wall. So imagine to yourself that basement is a huge moisture movement. Block walls is a good clue here. That moisture movement is indeed causing us problems. And as we get to, the Greener Homes Initiative, insulating better job of insulating basements, boy, we're going to want to be really careful about managing moisture in basements before we go ahead and change their drying potential by putting insulation on the inside. And there was 3 really important clues to this house, and one was that there was acute asthma problems with the house. The father had also had chronic fatigue, and they had a consultant who came into the house and within a few hours got sick. So when you think about the clues of this, we see signs of moisture. People are getting sick. What do we do? And the answer is gut the basement. I'm going to be really blunt. Gut the basement. There's no ozonators, ionizers. There's no UV lights that are going to solve this. A dehumidifier is not going to solve this. Ripping up the carpet isn't enough. You need to imagine, because of those 3 strong clues, people sick in the house, the visual signs of moisture, and in fact, the smell in this case was the 3rd clue. This house needs to get the basement needs to get gutted. And how do we manage the moisture in that basement? I'll show you in a second how we're going to do that. We historically, of course, have been using fiber insulations on walls. And we're starting to recognize that this is really challenging to use fibers on basement walls, especially when our codes still require us to be using vapor barriers on the inside of our walls. Basements want to dry to the inside. Say that again. Basements want to dry to the inside. And I need to do one of 2 things: keep the moisture in the concrete, or don't insulate to the inside, or use insulation materials that allow that water vapor to dry through to the inside and manage that. Because there are indeed all of these technical issues around basements, the many moisture problems, the soil dampness, the rainwater runoff, the construction moisture, summer condensation. And we know the strategies really nicely. 1, improve moisture management from the outside. 2, insulate late in the process. Grade early, insulate late, and only insulate if you know you've got good, proper water management. And then that bottom one, dehumidify. And there's a lot of builders, a few builders on this call. I know your names. You're providing dehumidifiers in new houses. Thank you for doing that. Every builder in Canada, and I say that advisedly, in Canada, need to put dehumidifiers in basements. And you can say, well, I'm in a dry climate in Calgary. Your basements are still moist. The soils are moist, and they're trying to dry to the inside. Everybody should be putting dehumidifiers at least offering the capacity for dehumidification in their houses. And you guys know the answer is good drainage. On the right-hand side, the Dorkin drainage products, the Delta Dries and so on. On the left-hand side, a draining insulation product. These all work really, really well. Steffi, was there a question? Are we okay?
Well, there was a question that came up and then you mentioned dehumidifiers. So I figured I would just hop on. So they wanted to know if you could suggest an in-house dehumidifier to maintain relative humidity, or if you have some recommendations on that front.
Yeah, as a starting point, I will say, actually, can I save that one to the end? Because I do have a slide on it.
Sure, yeah.
Yeah, thank you. I'll hand you that one, or I'll give you that answer back or remind me of it. So these drainage layers on the outside, I think, are really powerful to understand. Oops, sorry. I wanted to show that animation of the kinds of detail that you want to get to, of, that understanding that basements are going to be an issue, that good drainage layer on the outside, stopping that liquid water flow coming through and keeping that foundation drier. You'll notice here, they're not even using a damp proofing on the wall. I would still say a damp proofing behind that drainage layer to stop that capillary flow through that concrete as well. But a good drainage layer on the outside is where we'd like to head towards in all of our basements. And I just want to give you a sense of, trying to make those fibers work. In this case, using a smart vapor barrier. This is Doug Terry, our good friend Doug Terry, who uses a smart vapor barrier, a vapor barrier that changes its characteristics depending on its moisture content. So in the summer, it actually opens up, becomes more vapor permeable, and allows it to dry to the inside. Code says you have to use a vapor barrier. Doug's using one, but he's using one that gives him variability so that in the swing seasons, or at least the difficult season where moisture's trying to dry to the inside, he has that ability to allow that moisture to go through. So that's a membrane. It's called Membrane. It's from Certainteed, a really cool product that you may want to think about. Here's how other places in North America are doing this. In Minnesota, interestingly enough, Pat Holman, John Straub. Pat Holman at University of Minnesota, John Straub at University of Waterloo. There was a joint study undertaken on basements. Out of that study came the recommendation we should really insulate from the outside. Minnesota actually put it in their code. Ontario said, we'll think about it a little bit. And in Minnesota now, you cannot insulate in a new house. You cannot insulate on the inside of a basement wall unless you've already insulated on the outside. In other words, they're moving their insulation to the outside. Pretty interesting, right? That means the concrete is warm. And in the building science world, warm equals dry. So they insulate to the outside. And it's pretty cost effective, especially if you're not going to finish a basement anyway, to say, let's just go ahead and dump some insulation on before we backfill. The issue always is, what do I do with the above grade portion? Well, as time permits, go to Minnesota. They have about 4 solutions. They've got a stucco coating they put on. They've got a product called Groundbreaker, which is sort of a rollout vinyl product that makes it look like a concrete. They have a parge coating and so on and so on. And they have a embossed metal panel as well that goes on those outsides to finish off the outside wall. But insulation on the outside is a really, really good choice, something you want to keep in mind. And interestingly enough, even if you don't insulate, put all your insulation on the outside, or if you just insulate the below grade portion, that dramatically improves the potential on the inside. That is, if you put insulation below grade on the outside and now do full height or almost full height insulation on the inside, that basement wall got warmer. Less moisture was in that concrete, less moisture movement. Those walls tend to do better. So work with your energy advisor to say, could I get some credit for putting insulation below grade? And what could I do on the inside to reduce the wetting potential or the condensation potential? So something to look at in your basements. Let's start thinking about insulation to the outside is where we'd like to get to. Some of you may have seen this animation before, but again, my partners at CI, this is the quintessential renovation of a basement. If you've gutted that basement, which you would have with that smell, you go ahead and put extruded polystyrene foam. And you do want specifically extruded foam in this case. You don't want EPS in this case. Not that EPS can't work, but this extruded works a little better. It has just the right vapor permeance. You put it tight to the wall. It's showing spray foam on the rim joist, which is great, doesn't have to be. Now you put your stud wall up, and you're gonna say, well, could I not just spray foam the whole thing? And the answer is, of course, you can spray foam the whole thing. But in this case, trying to be cost effective, using a standard frame wall, And then this is showing a blown in insulation. It doesn't have to be blown in. You can use bats. The magic here though, watch what doesn't go on this wall. What doesn't go on this wall. When we get to the drywall phase, the drywall goes on without a vapor barrier. And you go, like, building compartment requires a vapor barrier. Not if you do the calculations correctly. If I pan to this wall, notice that if I have just the right amount of extruded insulation on that wall, I can show that that's the point of where the dew point is going to be, and I can show that I do not need a vapor barrier on the inside, or maybe I'm using a vapor retardant paint. The magic of this wall is any moisture that's coming from the outside gets stopped by the semi-permeable XPS and stays within the concrete, and the concrete doesn't mind being wet. Any moisture that's coming from inside the basement towards the wall, instead of hitting cold concrete, is hitting a warm foam. No chance of condensation. This is a great wall. John Straub basically is the one who drew this up as part of that basement study. This is a great wall that you want to think about. It typically ends up being 1 inch to 1.5 inches of extruded on that wall is what you want to look for to get that sweet spot of not requiring a vapor retarder, vapor barrier on the inside. And then from a basement floor perspective, I just love showing this. You know, we worry about the basement floor, and yes, you should never put insulation on or flooring on a basement floor until you know it's moisture. But this is a really nice product. This is again a Dorking product. There's various versions of this from other manufacturers, AGT and others. But a dimpled plastic, it does 3 things for you. 1, it stops the moisture. It's a moisture barrier. 2, it gives you a little bit of an airspace, so you get a little bit of insulating value. And 3, if it does get wet, it has the ability to drain and ultimately dry. So look for better basement solutions along those lines. So, and then I noticed again, or mentioned again, this idea of a dehumidifier down in basements. I'm still gonna, that's a portable. I'm gonna show you a better choice than a portable, but insulate late, manage that capillary flow, the wicking of water, manage surface temperatures with better insulation ideas, and then facilitate dehumidification. Let's move to above grade walls. We're doing pretty well on time. Stephanie, any questions? Are we okay? I don't see your face there, so I think we're good.
We do have a few. I just didn't want to break your rhythm there. You were.
I know. I talked to her.
You were trucking right along. That was excellent. So back to the dehumidifier. So one of the questions was, does the dehumidifier need to run throughout the year or only in the winter? And what is the best relative humidity for an occupied basement?
Right. So the first answer, or the last one, we know, right? What's the right relative humidity? 50 plus or minus 5, 50% plus or minus 5. Now basements maybe get to 55. I'm okay with that. And oddly enough, or interesting enough, they don't need to run in the winter. Why? What's a dehumidifier doing? Well, it's taking warm, moist air, cooling it off to drop the moisture of it and warming it out of it and putting it back to the house. It's making cold air. Well, in the wintertime, we don't need to make more cold air. We already got lots of cold air. That's called outside air. So in the wintertime, you don't need a dehumidifier operating. You need a ventilation system operating, HRV or ERV. The dehumidifier starts running, and you know the clue, when the temperature outside is above roughly 10 degrees Celsius. When the temperature outside is reliably above 10 Celsius, maybe 12, maybe 15, that's when you say, I'm going to start running the dehumidifier, because now the outside air doesn't act as a dehumidifier. Now, don't be mistaken. That doesn't mean you turn off the HRV. The HRV still needs to be there for ventilation, but it's not acting as a dehumidifier in the late spring over the summer. I still need the ventilation, but I need the dehumidifier to cause the dehumidification function. Hopefully that answers that one. And so it doesn't run year round. It runs summer, spring, summer, fall.
Thanks, Gord. Another question is, in the insulation options slide, it looked like there could be a thermal bridge at the top of the external insulation.
Sure.
So how would you resolve that?
Yeah, it's a great question. You know, depending on those insulation options specifically for basements, I need to manage that outside. That's why I love insulated sheathing. You think about insulated sheathing on the above grade walls and insulate on the outside of the basement wall. Wow, now it lines up. This is actually really cool to think about that, is I use insulated sheathing above grade and below grade. Now there's no thermal bridge. That's the best solution, frankly.
Okay, there's a couple more questions that came in. So one was, can you use an ERV without a dehumidifier?
And the answer is sure. Well, again, I'm going to save that one to the end, and hopefully we have time for it. But yeah, save that one to the end.
Another one was, when putting insulation on the exterior of the foundation, how would you address it above grade if you have brick or stone? I think you did mention that in Minnesota. I'm hoping to not have the insulation stick out beyond the brick, but the insulation cannot support the brick. So I'm wondering if you have a good detail.
So here's what they do in the U.S. They use a brick lintel. They do not necessarily push out their foundation. They don't put a brick ledge on their foundation. They just hang the brick over with a metal lintel, big steel lintel underneath the brick. That's one option. There was at a time, and you may be able to find it now, there was a top block, I would say, or a base block that actually hung over the bottom piece, and you could still think about that. Yes, the insulation's still going to hang out to the outside, but we could think about that. There are systems to put the insulation within the concrete. That's called T-mass. So the insulation could be in the middle. And then if you talk to the ICF guys, they would say, well, we have a flared form, right? The ICF guys flare the form out, and so the brick ledge sits on top and it doesn't fall out. I keep challenging the basement foundation guys, the traditional guys, give me your flared form. Give me a form that flares out at the top so that I'm able to get that insulation without the problem of the brick with the insulation hanging out over the top. So it's not an easy detail. I'll agree with you. Depending on the aesthetics, you're going to have to think about how I get that done. But there are a couple of solutions.
The last one was, it almost sounds like basements in general are a bad idea for new construction. Did I get that right?
Well, I would say don't call them basements anymore. Call them lower living area and spend money on them. If you're going to live, it's really hard to live in holes in the ground. The last two houses we built, we did slab on grade. And my builder, Derek, he may be on this call, is like, really? You don't want a basement? I just don't want the hassles of basements. Why would we do that? So could you build without basements? The answer is yes. If you are going to build basements, then you really need to think about they're below grade. And I need to do a better job of keeping them warm, dry, bright. We have the technology, the drainage layers, the insulation products. We all have it. We just need to remind ourselves it's not as easy as it used to be. We need to be reminded. Most people are not going to shoot hockey pucks in basements. They're going to want to finish them. And the minute they finish them, and even whether you finish them or they finish them, when they have a moisture problem, they're calling you. So we have the technology and some great builders. TerraView is doing it. Reed's was doing it. Doug Terry's doing it. I'm just naming builders that I know do a great job of basements. Derek Seaman, does a great job of basements, understanding the products that are most conducive to a good basement. So build without them if you can. And if you are going to use them and they're going to use them as living space, they are, spend a little more money on them and make them truly livable space. So hopefully that helps. And I'll move ahead. And, we always like to show the Armageddon slides. Water is a very powerful force. This building's less than 7 years old. Notice one of the big clues. One of the big clues is that yellow stuff, insulation. This wall got wet, wasn't able to get dry. This is actually a stucco house. Stucco lasts for hundreds of years, but stucco doesn't last for 100 years if I don't have good drainage and good drying potential. And when we think about, and this was black paper, and could the black paper have worked? Yeah, if it was able to get dry, but because the wall was insulated, it really didn't have the same drying potential. I'm asking you to rethink the way you're doing things. Now, this is a proprietary slide. This is an animation that was drawn for Tyvek. You don't need to necessarily look at the brand name, but I want you to look at the details. Look at that bottom of the wall detail, that cold joint at the bottom and a kick out flashing at the bottom of the wall to make sure water gets away from the foundation. And then the water resistant barrier on top of that. That's actually showing skip tape at the bottom, which would allow water to drain out if it needed to. Notice the bead of caulking at the top, which helps turn this water resistant barrier into an air barrier. Notice the laps. Why do we lap 6 to 8 inches? Because water can wick 6 to 8 inches. So overlap those materials to get them done correctly. And then this is showing tape at the top as well, just to think about air barrier is what we'd like to get to. And then taping the seams, the proper size, the proper width of tape is what we want to get to on the outside wall. And all I'm showing here is the proper fasteners. Stop using staples and use button cap fasteners at the proper spacings, using a water resistant barrier that has, remember the 3 properties, water holdout, air holdout, vapor permeance. But the one I really like to key in on, because in the field itself, that is the house wrap, I don't care whose it is, they typically don't leak. It's when you put a hole in the house wrap that it starts to leak. And the biggest hole is windows. And I'm going to count for you, put your fingers up, or maybe put a tick on the page of which of these you get a point for. I'm going to tell you there's 10 key elements to a properly installed water managed window. Element number 1 is a slope sill. If you're sloping your sills, put a tick mark on the page. If you're not sloping your sills, you don't get a tick mark. Not saying you're a bad builder, you're just already working out of 9 out of 10. You can get a half point if you back dam. That is if you caulk, not foam, but if you caulk the underside of the window. Point number 2 is a fully developed water-resistant barrier shingled with proper fasteners, proper tapes. That's point number 2. Point number 3 is the proper eye cut to protect the jambs at the side, to leave the head and the sill clean. You'd like to leave the head and the sill clean. That's point number 3. Point number 4 is shingled up at the top, being able to pull it up at the top to allow the window to go underneath. Point number 5 is a fully protected sill, a sill pan flashing. It doesn't have to be this one. There's metal pans, there's plastic pans, there's peel and sticks that you can use. Point number 6 is J-rolled. Make sure that we have pressure rollers. Point number 7, caulked on 3 sides. Don't caulk the bottom because I want to let water out. Point number 8 is the window going in with proper fasteners at proper spacings. Point number 9 is side flashings. 10 is head flashings, shingled and lapped, back down over top and taped off, in this case, skip tape. Those are 10 key elements. Give yourself a bonus point if you put in a head flashing above that window, or a half point if you do that back dam. So just imagining yourself, how many points out of 10 do you want to be? If you're on the, I don't know, the East Coast out on the rock, you would say, we got driving winds. I probably want to be 10 out of 10. If you're in coastal regions of Vancouver, I want to be 10 out of 10. You're in Calgary, I don't get that much water. 7 out of 10, 8 out of 10. I don't know. I'm not saying, all I'm saying is score yourself and you decide how many points you want to be at. And you're going to say, I'm only doing 5 out of 10 and my windows don't leak. And I would say yet, or enough that people notice. That's my point. Not all windows leak. You can do them badly and they won't necessarily leak. But I see on my day-to-day visits, as I said to you in the last 6 weeks, 5 different moisture intrusion problems, all of them caused by simple things like you're seeing here is important. Oh, and just so you're aware, the National Building Code of Canada requires head flashing. If your windows are not protected by overhangs, you're required a head flashing. How many of you are putting a head flashing? There's the detail of the head flashing. Notice the leg on the back edge up 2 inches, a drip cap over top to make sure that water doesn't leak in. If you're not protected by overhangs, then you need to be putting in head flashings. And here's just a little sequence or showing what that looks like. It's got to have end dams to it, and it's got to have that 3/8 of an inch drip over the front edge of that. So just thinking about the elements that we want to get to. And if you don't want to have your siding guy bend up one, here's one that you can buy, a little product called SureSill. I like showing it because it's a pre-manufactured little piece that's got some end caps to it you glue on that have end dams to it. Kind of a simple little product to get you protection when you don't have overhangs. You think about those big gables, you want to get that protection. And then you would think about, I mentioned to you, there was that flexible flashing detail. Well, here's a pan flashing, a plastic pan flashing. This one, oh, sorry. This one you might want the rigor of, let's see if I can get it. This one you might want the rigor of this underneath, say, a patio door where you know there's lots of movement in and out. So thinking about different materials that you could be using. And in terms of windows, if you don't want to use that flexible pan, you don't want to use that plastic pan, then let's just use a peel and stick and put these little plastic corners in so you don't have to do an origami to make sure that you're sealed at the corners. Oddly enough, remember I said walls don't leak, windows do? Windows leak at the top, do all their damage at the bottom. And when they do damage, they never do damage in the middle of the sill. They always do the damage at the corners. So if you're just going to do one thing, fix the corners of your windows and pick your poison as to which ones you're willing to work with as we move through this. That's where you want to get to. And if you're saying, well, that house wrap went in before the windows went in, here's a little animation that shows you how you could do your windows first, because in many cases your framers are putting in the windows. This is just showing you, I'm sorry, I got the wrong animation. I won't play this one after all. My apologies, I won't do that one. I wanted to show you one if you're using foam insulation on the outside, and you're gonna say, could the foam be my weather barrier? And the answer is sure. Is it shingled and lapped? No, so I lose a point or two. I got to use the right tapes. I can use foam as a weather barrier, but would I want to put in a head flashing? And the answer would be probably would, because I don't have a flashing. I don't have that shingled and lapped above that window. So if you're going to use foam as a weather barrier, make sure you're doing it correctly. Now, so here's just showing, though, if you want to do house wrap over foam, we often get asked, how do I do house wrap? And frankly, it just comes down to this. You buck out the window the same as you would normally, buck out the window the same thickness as the foam insulation that you're going to use. And you're going to say, well, there's a thermal bridge through that frame. It's a very small thermal bridge. I'd rather have the window attached correctly rather than worrying about that last little bit of thermal. There are some products out there. There's a product called Thermal Buck, which would give you the thermal strength, a value through that stud location as well. But notice this, the house wrap is going on pretty much the same as it normally did. All I need to make sure is I have a slightly longer fastener that gets me back through the foam. So just a little example of where we're headed with this. So house wrap is really no different, just going over top of the foam in this case is where we're headed. So I'll just, in the interest of time, give you that one. I mentioned brick earlier, and I just wanted to remind you that brick is incredibly forgiving. You know, it's got this really nice, assuming it's a clear airspace, really nice space behind it that gives us three elements. It gives us drainage, it gives us venting, and it gives us drying potential. So brick cladding is incredibly forgiving, really nice. What you want to imagine is every other cladding system mimicking what brick will do for you. That is, you'd like behind wood-based products, behind engineered products, behind stucco, behind synthetic stone, you would like to mimic the attributes of the brick system to make sure I have good drainage, good drying. Doesn't necessarily have to be a full inch, but you would like that good drainage and drying potential. And here's a little example of an animation of, you know, that getting that brick on correctly. Again, notice that bottom of wall, that through wall flashing that makes sure that the water, and that could be a metal, that could be a membrane. Notice the flashing detail there, the tape, to make sure it's sealed. Again, we're putting on a water-resistant barrier in this case. So putting on a water-resistant barrier, some would say, well, I'm using building paper. All right. Again, I would say it doesn't have the same drying potential. Make sure you're using the proper fasteners in this case. But what I wanted to get to is, this again is a proprietary system, but you get the idea. Hopefully you don't mind me showing a manufacturer. They paid for the animation, so I figure I better let them play them. And notice this little detail here. I don't want that brick venting into the soffit. Oh, I don't want that. So I want to create a detail that allows the brick to vent, but below the soffit. Notice the brick ties going in, making sure the proper spacings bent up, not down, to manage water. Notice this mortar net to make sure that there's no perched water on that mortar. So just keeping the mortar, keeping the airspace free down at that bottom. And then the weeps going in just above, the weeps going in at every fourth brick or whatever that standard is, and allowing that water to get out of the building because of that flashing detail. So it's that through wall flashing that I'm really trying to key on. Bottom of wall, think bottom of wall. When you go back today, look at bottom of the wall and how well I'm doing it. And then top of wall to create that airspace so that I've got good venting of that moisture, that thermal, that moisture in behind that wall. Very powerful. Hopefully you'd agree. Pretty powerful stuff. So just showing that moisture venting out. Good, thank you for that. And then there's an example of a peel and stick. I'm gonna say up your product specs. I see a lot of, the old black plastic, the thin black plastic. I would say you wanna get something more rugged, more rigorous. You need to think about, what am I doing on an outside corner? What am I doing on an inside corner? I got a Christmas present wrap these, to make sure that I have really good rigor. And in fact, you'd like it to be seen. That is, I don't mind if you cut this one off on the right, but ask the bricklayer, I actually want this coming out so I can see it, so the building official can see it. We can cut it off later, but take a picture of it so people know it's there. People aren't going to like the look of it. I'm sorry. I want it there. I want it continuous to make sure that water is getting out of that brick. I'll remind you again, brick is incredibly forgiving because of its airspace, but you take away many of those advantages unless you've got that really good bottom of wall detail to make sure that I'm not going to have moisture issues. And then I just wanted to give you a little shot on window sealants. I often see, remember I mentioned back damming on the inside. We normally see foam done on the inside of a window, even along the bottom. And I'm going to say to you, think again. We've tried in the lab, our facility in Denver at CI Live, come see us sometime. But we've been trying different foams to see if they're watertight. And it turns out foams don't do a good job of keeping out water. Foams do a nice job of keeping out air, give you a little bit of thermal, but we would suggest on the bottom of the window, set up your rough stud opening such that you caulk the bottom up 6 inches on the side, a good caulking like a LePage Quad Max, something like that, that gets you a good caulking bead. That gets you, instead of, if you don't want to slope the sills, we would always say, you know, it's not a leak if it leaks to the outside. If I have a good sill pan and I back dam, now water is leaking to the outside, not the inside. So rather than foaming the bottom, caulk the bottom. If you say, well, I want to foam first in deeper and then caulk, that's fine too. So foam goes in first and then caulk the outer edge would be a nice way of getting there. And then I want to say to you, I see this all over Ontario, these tapes are not approved as flashing for windows. They don't seal correctly. They're not compatible. So these are sheathing tapes, whether they're blue or red, these are, or white or whatever. These are sheathing tapes. If you look them up, they are approved for one thing and one thing only, and that's to attach one synthetic sheathing material membrane to another synthetic membrane or the same membrane. They're not designed for windows. Get over it. You need a better detail. If you're doing, if you're relying on tapes on the outside, use an actual flashing tape, a butyl-based product, 4-inch wide. Make sure they're using compatible tapes on the outside. And then, of course, you need to think about penetrations and making sure you're doing the, I would say the one on the left, a boot is not a proper hole drilling tool. But here's a, a simple little product called Quick Flash that you can use on plumbing penetrations, you can use on HVAC penetrations and so on. You get the idea here. That's just simple. It means the pipe can move. What I often see is people wrapping tape and wrapping foam. The tapes and the foams are not watertight. The tapes and the foams are not watertight. If anything, I see them actually encouraging water to come in. And it's not a big hole, I get that. And maybe it's not exposed, it's underneath a patio, I get that. But if you really want to do it right, you would use that kind of detail. Here's another choice. This is a flexible tape, a tape that flexes, butyl tape that flexes around that opening. So by all means, go ahead and use that one. That's gonna work just fine. Look at the one on the right. The one on the right is the one I like the best. The line sets. If you're doing air conditioning, putting in an air conditioning line set, boy, that's a really difficult spot. It's really difficult to water seal that. And I see it foamed, I see it taped, it doesn't work. This is a flashing boot, much like you'd see a flashing boot on a roof penetration. This is a flashing boot designed specifically for line sets and designed specifically for brick. So pretty powerful little flashing detail that manages the water potential through that line set. So just a little example of that one. How are we doing for time? Not too bad. I'll keep moving, Steph, if that's okay. There's just, roof to wall intersections. I just want to make sure that we're using kick-out flashings. The one on the left is a drawing from Journal of Light Construction. Draw it up as a little bent metal sealed. There's a product on the right called DryFlex, comes out of Nashville, Tennessee, I think it is, or Knoxville. And it's a simple little product that just ensures that you have good water running away from your walls. Good. When you do the roof to wall intersections, let's make sure we get those done correctly. And then I would say, test your walls, come down to CI Live. We love coming down, having builders come down. Some of you have already been. We have this facility in Denver, 8 minutes from the airport. You get to build a wall in the morning and the next morning of day one. And the next morning after things have set up, you get to go put your window on a spray rack and see if it leaks or not. It's a real eye opener. If you're not doing that, then if you don't want to come to Denver, just put a hose on your windows now. Not a hose, a sprinkler on your windows. Wait 20 minutes, see what happens. I would challenge you to start measuring your walls. I find it fascinating, 10, 12 minutes, what starts happening with windows. So make sure you're testing your walls. And then as we finish up the session, there was questions on ERVs and HRVs. I just want to do just a little bit on indoor moisture, a little bit more. You remember the number, summer moisture, 50% plus or minus 5 is where we'd like to be. What I want to remind you is this: sensible loads are on their way down. That is, the heat flow through walls, the heat flow through windows is down because, and that's a good thing, because we've added more insulation and better windows. The latent loads, the moisture loads are on the way up, partly because we're spending more time indoors and partly because we have now more reliable ventilation. The chart on the bottom, I won't make you do it today, but I'd love to have a class with you where we go through the psychometric chart and show you when you're at risk and when you're not, where ERVs work and where dehumidifiers work. All of this can be done on paper pretty simply. And I love giving people an 11 by 17 psychometric chart and have you work through those exercises. So I'll shortchange you a little bit today, but just to tell you, it's all physics. This is not guesswork. We can define all of these elements. And I just wanted to show you this this is showing Southern Ontario, but think of any place where you're doing air conditioning, any place that's hot enough that you need air conditioning. Typically, we're in this kind of range in terms of moisture. And if you look at the moisture sources, remember that 50%, the moisture sources that are impacting that. The first moisture source is the moisture created by the occupants. And you and I will know we can't do much about that. But that's 8 to 12 liters of moisture a day. And it's in the order of, it could be as high as 25 liters a day. The second is moisture coming in from air leakage. You want to make your houses tighter. The tighter you make your houses, the less moisture comes in the summertime. That's a very powerful thing. The third moisture movement is by ventilation. The more you ventilate, the more moisture comes into your buildings. You can reduce that by making sure you have only the right amount of ventilation, or as you'll see in a minute, use an ERV. The fourth type of moisture is moisture that's coming in via vapor diffusion. That is through the OSB itself, through the drywall. And it turns out that's a relatively small amount of moisture, nothing you can do anything about. And the fifth type of moisture is the moisture inherent in the building materials themselves at the time of construction. Again, not much you can do about that. And the good news is, after about 18 months, that's stabilized out. So there's 5 moisture sources, 3 of which you can't do anything about. You can't do anything about the people, more or less, unless they're being really goofy. Can't do anything about the vapor diffusion at this point. And you can't do anything about the moisture that's in the building materials except proper drying, dehumidification. So the only 2 that you have control over, quite frankly, in terms of getting rid of, is make your buildings tighter. The tighter, the better. And 2, making sure you're choosing ventilation systems, not oversized, but ventilation systems that give you reduce the amount of moisture that comes into the building. So, and what I think you should find really fascinating is the difference between that nice, comfortable 23 degrees Celsius, 50% RH, and really risky, like 60, 65%. Only an extra 3 to 4 liters of moisture evaporated in the air. If I took a 4-liter jug of moisture and evaporated it into the air at any point in time, that would increase the moisture from 50% up to 60 to 65. Wow. In other words, it's pretty tenuous, right? We have all these sources that are happening on a continuous basis. In order to manage that moisture, we had that difficulty. And how did we used to manage moisture is really the issue. I think I'll go to this one first. Sorry. How did we manage? Oh, sorry, I got the wrong one again. How do we manage moisture? And the first thing we could think about is using our air conditioner, but using our air conditioner better. Either making sure the air conditioner is installed correctly so it properly dehumidifies, or going to a 2-stage air conditioner, which has a dehumidification cycle. Many thermostats now have on them a dehumidification cycle that will allow you to run the air conditioner at I'll say lower fan speed so it gets better dehumidification. I don't have it on the slide. I thought I did. Write down this number. The dew point of 23 degrees Celsius air, 50% RH, you remember what it was? 12 degrees. The air coming off the air conditioner, if you're trying to dehumidify that air, you'd probably want it to be below 12 degrees, right? So here's what I need you to do. If you want to know if your air conditioner is properly dehumidifying, stick a temperature probe just above the coil or even out of the first vent when it first comes out. If that air isn't getting below 12 degrees Celsius, thereabouts, your air conditioner is not providing much dehumidification. So that's a simple test all of you can now do if you have high moisture complaints in the summer, and you'd like it to be at least 2 to 3 degrees, maybe as many as 4 degrees Celsius lower. So you'd like the air coming off the coil to be in the 9 degrees Celsius range in order to get good dehumidification. So how do I manage that moisture? Let me go back up there. One, I could start using ERVs. And I'm going to say to you, if you're air conditioning at all in your climate, you probably want to start using ERVs as the basis of design. They are not dehumidifiers. All they're doing is reducing that third element. Instead of 20 to 25 liters of moisture coming in, they're cutting that in half. ERVs take out half of the moisture difference. They're not dehumidifying your house, but they are reducing the moisture load due to ventilation. So get to ERVs if you're in air conditioning mode. And there's some great new options out there, great new models, HEPA filters, and so on. And then say to yourself, I want whole house dehumidification. Of course, portable dehumidifiers, Energy Star rated portable dehumidifiers, I guess that's my hint. Buy an Energy Star rated one, they're all pretty good. But I'm going to say to you, pros on this call, custom builders, you put in whole house dehumidifiers. There's great companies. Honeywell's got them. April Air's got them. I think the best of them is a company called Thermistor, Ultra Air. They have now one that sits in a wall. It's a beautiful device in a basement wall that's unobtrusive. These are ducted versions. They're ducted into, you can actually see it here on the right-hand side. They're ducted into your furnace system, and they give you whole house dehumidification. So 1, set up your air conditioner better. 2, ERVs, and 3, dehumidifiers. Could I get rid of one of those 2? And the answer is probably yes. If you went to 2-stage air conditioning and ERV, then maybe you don't need the dehumidifier. If you're not going to twig or tweak your air conditioner, then you probably need all 3 of those in order to make it work. So I love whole house dehumidifiers. So as we finish up, at least this portion, maybe they'll have a chance for a few questions. 3 things to work on, hopefully you heard. 1, liquid water management of windows and the walls. Sorry, it should say, what does that say? Oh, and the holes that are in them. Management of windows should say of walls and the holes that are in them. In other words, water management of windows. 2, let's touch up our basements to make sure they're truly livable space. And 3, enable a moisture balance year round. And specifically, I'm thinking about dehumidification in the summertime to get to that 50 plus or minus 5. And so the summary, moisture is a bigger issue than ever before. And your customers are indeed looking for answers. That's why I've been out doing warranty investigations of late. The expectations and codes are going to drive even more change. And it's okay for houses to leak as long as they leak to the outside. So good drainage is what you're looking for. Windows are your biggest issue. Spend more time and effort on making sure the windows are installed correctly. And then recognize that all houses need the capacity for ventilation. So ERVs do a better job of that. So you're going to want to start moving towards ERVs. And basements need special attention. So that's kind of the summary. You're thinking about airtight thermal comfort and helping avoid those, will help avoid those issues. So that's kind of where we're at. Steph, any questions?
Yeah, we've got 9 so far.
Oh.
So yeah. Okay, so first question is, will using styrofoam, then insulation, in addition to a vapor barrier in the basement, cause a humidity problem?
The answer is the right combination of foam. If you're using, people talk about double vapor barrier. It's only a double vapor barrier issue is if where you've achieved the dew point within that wall. If you put enough foam on the wall, then the vapor barrier can be there or not. So you just need to do the calc. We can do it for you. Any EA should be able to do it for you. You can do it yourself off the code. So enough foam. It's a ratio of the insulation. The more insulation you put in the cavity, the more foam you need. If you put foam and just R12, that needs less foam than if you're putting R20 bats. So it's finding the right ratio, and in which case the vapor barrier becomes a non-issue. So you can still do the vapor barrier if you needed to by code, as long as you have the right amount of foam and you do the dew point calculation.
Thank you. Do you suggest liquid flashing for windows?
I think liquid flashings are going to come, right? Especially for complicated windows. I see inset windows, I see round top windows, that you're going to see more and more liquid flashings. The key with liquid flashings is the substrate. The right substrate and its preparation, and the right mill thickness. You can't just slather on and go, I'm done. No, you got to slather it on, take depth gauges, and make sure that you had the right thickness. So, and then you'd have to think about, can I do them in winter? What temperature can I do them at? So I absolutely think fluid applied products we're going to see more and more of them. The custom builders, you're probably going to want to look at fluid applied, but this is not your handyman doing this. Well, maybe it is your handyman because maybe they're the most skilled. You need to understand somebody who knows a bit about coatings and mill thickness. I used to play with a mill thickness gauge. My dad was in the coatings industry. I learned really early age what the difference between 5 mil, 10 mil, and 30 mil thickness was. At the time, I didn't recognize it. Now I do. You need to get the right mill thickness. And you think about OSB. OSB, if I'm using a fluid applied flashing, OSB is really rough coating. How much do I have to put on? I got to put a lot on to cover that OSB. So depending on what your substrate is, you may need so much of it that you go, wow, that's not worth it. But I love fluid applied flashing.
Is there a resource for best practice for replacing windows?
Well, that's a really good question. SODAC is a good start. The Siding and Window Door Contract Association have a program on installation of windows. CSA has good. I'm going to say to you, every window manufacturer uses basically the same principles. And so just go to window manufacturer, or frankly, go to CI's website and look at one of the animations and go pick one that suits you, because there's inside, outy windows, innie windows, there's flange, non-flange. You have to find a methodology, absolutely.
Another question is, for ERVs, what is the exhaust air source? Usually exhaust is coming from bathrooms and kitchens, but I don't think you'd want that air mixing with the incoming. And is smell a concern?
Yeah, it's not mixing, remember, it's two separate airstreams. Two separate airstreams. Is there transfer of moisture? Yes, but there's not transfer of odors across the sheet. So you're still pulling from bathrooms and bathroom areas, and you're only getting 50% of the moisture reduction. But remember, that bathroom's only used for a few minutes, a few hours of a day. Most of the time you're getting what you want. So you're still pulling from the bathrooms. Absolutely. It's not an issue.
Another question is, can you provide an estimate on the cost premium for a basement lower level construction versus above grade?
Well, I can't, sorry.
Okay.
If you're saying to me to do it right, how much more does it cost to do it right? I always use this. Are we talking hundreds, thousands, tens of thousands, or hundreds of thousands? To do a basement right, you're talking in the order of thousands, not tens of thousands. I'm talking about a standard basement now, 2,200 square feet, something like that, or 1,000 square foot basement. To do it right, the proper water management details and so on, you're in the order of thousands of dollars. It's not tens of dollars, it's not hundreds, it's thousands, but it's not tens of thousands of dollars to do a basement right.
Another question that's come in. Now, this is a series of questions, so I'll try to group them together.
We only
a
have
bit.
A minute left.
Okay. So it has to do with a concrete foundation wall. Should outside concrete foundation walls have insulation on the inside or the outside, at least down to the frost level?
So I'll say again, you'd like to insulate on the outside. You'd like to insulate the outside. That keeps the concrete warmer. Warmer equals drier. So always insulate the outside. If you had your druthers, you'd insulate the outside. If you do need to insulate the inside, that's fine. But remember, now I have drying issues that I need to worry about.
Okay, so what I'll do is I'll just ask this last question because I know we have to wrap up here. With
Yes.
High expansion and contraction rates, would you stay away from vinyl windows with sun exposure?
Yeah, again, this is a really good question because we are seeing more and more of this, larger windows and then different colors of windows. So you're going to have to be really careful working with your window supplier. A couple of things start to happen. What is the quality of their extrusions? What vinyls are they using? Is it virgin and so on? You're going to want to start understanding the differences between the expansion contraction modulus for sure. And I'm not saying you can't use them. What I'm going to say is you need to recognize the materials around them better be flexible. So your flashing systems, your tape systems, the caulking systems are going to have to respect the fact that those large windows may be moving more and the vinyl may be moving more, and sun exposure is important. That's a tough window, west facing window on the lake, high expansion, black. Oh, wow. I want to be careful about the choice I'm making. So go back to your window suppliers, add another item to the checklist besides the price. Hey, could you get me the difference between your expansion coefficient and your competitor's coefficient, please? Because I need to see if there's any difference.
Okay, well, thank you so much, Gord, and thank you also to Enbridge for sponsoring this event. And of course, we want to thank all of you for joining us today. As I close out the session, a little window will pop up that has a Survey Monkey link. So be sure to respond to that survey. And just so that you know, our next webinar is with Gord again, and Rob Johnson is going to be joining us, and they're going to be talking about large building air testing and compartmentalization. So it's a really, really important topic as we see more large buildings being built. So thank you once again, everybody. Look for that email, that survey link, and I will send out the resource email with Gord's slides, as well as the video recording for today. Probably tomorrow, that'll go out to everybody.
Thanks so much, Stephanie.
And thank you, Gord. I appreciate it. It was always great learning. So have a great day, everybody. Bye.